In this video, I shall be discussing briefly on the topic molecular orbital theory. Okay, before we start on, I want you to go through the theory or assumption or postulates. Okay, now coming back to the molecular orbital. Molecular orbital is a combination of the atomic orbitals. So which means the atomic orbitals are combined to form molecular orbital. Okay, now for this molecular orbital, or for the formation of molecular orbital, it is best explained by LCAO, that is linear combination of atomic orbitals. Okay, then right after this brief explanation, I will go to calculation or how to calculate the bond order. Okay, now coming back to linear combination of atomic orbitals. Okay, now when the atomic orbitals are combined to form molecular orbital, okay, two types of molecular orbital are formed. One is called the bonding molecular orbital, and the other one is anti-bonding molecular orbital. Okay, for bonding molecular orbital, it has lower energy compared to the anti-bonding molecular orbital. Then according to LCAO, okay, whenever the molecular orbitals are formed, okay, the combination of the atomic orbitals will follow up this one. Okay, suppose we take the example of H2. Okay, so here the atomic orbital of H is combined with atomic orbital of the other H. Okay, we shall later on calculate the bond order. Okay, or just bond order, yeah, like this. Okay, so according to LCO, it is a linear combination of this atomic orbital with this atomic orbital. Okay, so during the combination, only those atomic orbitals will combine each other which have same energies, okay, or nearly equal energies. So if this is 1s, then this also should be 1s. Okay, these two have same energy. Okay, therefore they will combine. Then the next type of combination is, say, during the combination, the next one, yeah. So during the combination of atomic orbitals, they should have the same symmetry. Say for example, if it is 2px, okay, for the first atom, here in this example for hydrogen, okay, only 1s is there. But if we take oxygen, okay, then 2px will combine with 2px because same symmetry. See, along x-axis, this also along x-axis. Okay, then the next one is the combining of the atomic orbitals overlap effectively. Okay, which means the combinations of the atomic orbitals, okay, they overlap to a reasonable extent. Okay, now moving on to the next one. Okay, that is, see, whenever the two orbitals, okay, or the two atomic orbitals are combining, if it is head-on overlap, okay, then it will give sigma molecular orbital. Okay, if the overlap is sideways, it will give pi molecular orbital. Okay, now let us see how to calculate the bond order. Okay, so bond order formula is number of electrons in the bonding orbital minus number of electrons in the anti-bonding orbital divided by 2. Okay, let us consider one example, that is hydrogen molecule. Okay, so here hydrogen and here hydrogen. This is the question. Okay, so we draw like this. Here you can put box, or without box also it will be fine. Okay, then like this. Okay, the electronic configuration of hydrogen is 1s1. Okay, so here 1s orbital of hydrogen and 1s orbital of hydrogen. both of them they overlap, and this will give sigma 1s. Okay, this will give sigma star 1s. Okay, sigma star means anti-bonding molecular orbital, sigma means bonding molecular orbital. Okay, now you see from here one electron, from here one electron, so a total of 2 electrons are present. Okay, therefore now for a filling of the electrons, okay, so it will first fill from the lowest energy level, and this is the lowest energy level. Okay, that is according to Aufbau principle. Okay, so we first fill the electrons from here 1 and 2. Only a total of 2 electrons are there, therefore all the 2 electrons are filled in this sigma 1s orbital. Okay, now to calculate the bond order, okay, I'll come up here. See, number of electrons in the bonding orbital is 2, clear, minus number of electrons in anti-bonding molecular orbital, okay, or anti-bonding orbital is 0. No electron is present, so it will be 0 divided by 2. So it will be here 2 minus 0 is 2 divided by 2, cancel, is equal to 1. Okay, that means the bond between these 2 hydrogen is single bond. Okay, and the electronic the molecular configuration can be represented as this one, sigma 1s 2. Okay, we represent like this. See, this one we are not writing because no electron is present, so it doesn't make sense. Okay, okay, now let's try the next one. Suppose if it is C2, okay, if it is C2, okay, so C and C. Okay, so the atomic, the electronic configuration of C is 1s2, 2s2, 2p2, isn't it? So 1s, or see, this set will be for both of this carbon, isn't it? So this carbon also have 1s2, 2s2, 2p2, yeah, and this carbon also have 1s2, 2s2, 2p2. Okay, so 1s of this carbon will overlap with the 1s of this carbon. Okay, so I'll show it here. Okay, so this is 1s. See, okay, always there will be one bonding and the other one will be anti-bonding. Okay, so this is 1s of both the carbon. This will give sigma 1s, this will give sigma star 1s. Okay, the s orbitals they overlap to give only sigma, sigma molecular orbital. Okay, then 2s. Okay, so this is also s orbital only, so the s orbital they overlap to give sigma molecular orbital. So here it will be sigma star, and it is of 2s, so it will be 2s here also, sigma 2s. Okay, one is bonding, the other one is anti-bonding. Anti-bonding have higher energy, okay, compared to bonding. The next one is 2p, isn't it? So 2p, I've got 3 different orbitals. Okay, so this is 1. Okay, this one is, yeah, this one is pi 2px, pi 2py. Okay, you can write here 2px, 2py, and 2pz. 2px, 2py, and 2pz. Okay, 3 orbitals are there. Then here it will be, this is it. Okay, now this one will be sigma 2pz. this one is pi star 2px, pi star 2py, sigma star 2pz. Okay, then you see for the filling of the electrons, okay, this carbon also have 6 electrons, this carbon also have 6 electrons, so a total of 12 electrons are there. Okay, now we shall first fill from the lowest energy level all the 12 electrons. Okay, so 1 2 3 4 5 6 7 8 9 10 11 and 12. Okay, now for the calculation of bond order, basically number of electrons in the bonding orbital. This is bonding, this is bonding, and this set is bonding. 1 2 3 4 5 6 7 8. So 8 minus anti-bonding is 1 2 3 4, only 4. Okay, so 4 divided by 2 is equal to 8 minus 4. 4 divided by 2 is equal to 2. Okay, that means the bond between two carbon is double bond or 2. Okay, then if we have to represent this one in terms of their molecular configuration, then we can show it like this. Where shall I write? Okay, I'll just rub this one. Okay, yeah, so see, sigma 1s and 2 electrons here, so 2. Then next comes sigma star 1s and 2. Then sigma 2s, here also 2 electron, and sigma star 2s 2 electron, then pi 2px 2 electron, pi 2p y 2 electron. Okay, so we can write like this the molecular configuration. Okay, I want you to try for C2 plus. Okay, C2 plus and C2 minus. Okay, so C2 plus means 1 electron less, C2 minus means 1 extra electron is present. Okay, so you try for this one. Okay, so now the next one is for nitrogen, oxygen and fluorine. Okay, so here there will be a slight difference, okay, for nitrogen, oxygen and fluorine because of the energy difference. Okay, so how we start is like this. Suppose if it is N2, okay, then it will be, so this is 1s, okay, then this is 2s, and here it will be 2px, 2py and 2pz, isn't it? So it will be like this, single. Okay, then this. Okay, so 2px, 2py and 2pz. Okay, so this is n, the other n. So the total number of electron is 7 plus 7, 14 electrons. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, this one is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Okay, sigma 2pz, pi 2px, pi 2py. This one is pi star 2px, pi star 2pz, and this is sigma star 2pz. Okay, x and this is y, this is z. Okay, now the bond order is here. See, number of bonding is 1 2 3 4 5 6 7 8 9 10, minus number of anti-bonding is 1 2 3 4. Okay, so 10 minus 4 by 2 is equal to 6 by 2. Therefore the bond order is 3. Okay, then the molecular orbital or MO configuration, I want you to do it by yourself, and also you do for O2 F2 O2 2 minus. Okay, so you try for this 3.